Hello everyone. Today we are going to see how we are attending the battery schedule of the locomotive. So this is the battery box in which the batteries are housed. It is present under the locomotive, outside the locomotive, in the under truck area. Normally there will be 4 battery boxes in a locomotive and there will be 10 batteries in a locomotive. Each battery voltage is 11 volt and there will be 10 batteries and we will get a approximate 110 volt DC supply from the battery. So this is the battery box 1, this is the battery box 2. Like that there will be 2 other battery boxes on the other side of the locomotive. As a first step, we should do a thorough visual inspection of the battery boxes, whether there is any crack or damage, any foreign material hit. We should do a thorough visual inspection of the battery boxes. We have a fuse called additional CCBA inside the battery box 1. In every locomotive this additional CCBA fuse will be available in battery box 1. There is a fuse, another fuse called CCBA fuse, that is inside the locomotive. This is provided for extra protection of the circuits. That additional CCBA fuse will be inside the battery box 1 only. There will be a small door in the battery box 1. By opening that door we can remove the additional CCBA fuse from the battery box 1. So as a first step we should remove the additional CCBA fuse from the battery box. Okay, first we will remove all the battery box door fixing clamps. We will slack it and we will open the cover of the battery and we will blow the battery with air. The air should be without moisture, no moisture should be there in the air, and we will thoroughly blow the battery. This is the battery box of the locomotive. Mostly there will be 4 battery boxes in the locomotive and total 10 batteries. This is this big battery box and in this battery box there will be 3 batteries, and then this is the another battery box. In this battery box there will be 2 batteries. Like that one side 5 batteries and another side there will be another 5 batteries, so there will be total 10 batteries in the locomotive. These battery boxes are supported with the battery box fixing clamps. These are the battery box fixing clamps and this is the cover of the battery box. It will be closed with fixed with this battery cover fixing clamps. While blowing it should be ensured that no moisture content is present in the air. So as a first step we will remove the moisture content from the air using this method. Can see a compressor for getting the compressed air for battery blowing. The compressed air will be coming through this pipe for our blowing purpose, and we will take that pipe to the locomotive near the battery side and we will start blowing. So before opening the battery cover we are going to blow the battery box outside the battery box area. First we blow the outside the battery box area because if any moisture still present in air means it will be gone through that air. The moisture content will be won't remain there. So always we will go outside the battery box. Okay, here we are removing the battery box cover to attend the schedule of the battery. Normally in diesel locomotive e-road we are having mainly three types of battery, three company. The company names are Microtex, Exide and Jumbo. These all batteries are RDS approved, and in our locomotives we are mainly using mainly these three company batteries. Okay, this is the big battery box. In this battery box we can see there is three batteries, and this is the we are removing the theft rod for unloading the battery. Okay, next we are going to remove the wooden pack. Okay, during IC schedule, we will unload the battery from locomotive, and we will thoroughly check the battery for any leakage, any damage, any external damage. Uh, we will unload the battery only during the IC schedule, that is once in 6 months. Before removing battery, we must ensure that all wires are disconnected. After unloading the battery, we will check the battery container first for any leakage, crack, either damage. We will thoroughly check the container first. And after checking, we will thoroughly clean the container. In a battery there will be 5 cells. For each cells we will have one electrolyte indicator and one vent plug. Like that, here we can see 5 vent plug and 5 electrolyte indicators. The purpose of vent plug is that to emit the gases which is formed during charging, to emit that gases from the battery. This is the float gauge. Here we can see a red mark here and a green mark. The electrolyte level should be maintained within this level, and this is the minimum. And this is the maximum. The green mark is the maximum, and the red mark is the minimum. So here we can see the electrolyte level is below the green level. So we are going to check the specific gravity of this cells electrolyte. Okay. This is the full picture of the float gauge. So here we are going to check the specific gravity of the electrolyte using a hygrometer. So in the hygrometer gauge we can see the level is 1250. The specific gravity is 1250. So here we are going to check how we do the vent plug service of the battery. Okay. The removed vent plugs from the battery, we will keep it in distilled water, and we will add some soap powder in it, and we will soak it for 15 minutes. After keeping it in distilled water and soap powder for about 10 to 20 minutes, we will dry the vent plug outside for about half an hour. After that, we will blow the vent plug with the compressed air. The air should be free from moisture to remove the remaining moisture from the vent plug. After blowing, we are going to test the condition of vent plug. We will keep it in a test stand and we will apply forced air into the vent plug. Here we can see the pressure gauge. If pressure goes above 0.8 kg per centimeter square, means the vent plug is not in good condition and it cannot be provided on the battery. Here we can see after applying the compressed air, the pressure goes beyond 0.8 kilogram per centimeter square. So this vent plug is damaged and it should be serviced, and after servicing only we can provide it in the battery. Now we are going to check a serviced vent plug. We will fix the vent plug in the test bench and we will apply the air. Here we can see the air pressure is not building beyond 0.6 kg per centimeter square. So it is below 0.8 kg per centimeter square. So this vent plug is in good condition and it can be used in the locomotive. Before providing good vent plug in the battery, one more thing we have to ensure: there is a rubber gasket available in the vent plug, and we have to ensure the condition of the rubber gasket. The rubber gasket should be in good condition and then should not be any crack or any other defect in that rubber gasket. Now we are checking the specific gravity of each cell. If the specific gravity is within the level, means 1220 to 1260, no need of adding acid. So in this cell also the specific gravity is 1250, and that is within the limit. So to maintain the electrolyte level, we will add distilled water only. Now after adding distilled water, the level increased. Okay, now we are providing the serviced vent plugs in each cell. During IC schedule, we will remove all the vent plugs and we will provide the newly serviced vent plugs during IC schedule only. In each battery there will be two legs, one positive leg, one negative leg. So during schedule attention we should check the condition of legs. There should not be any flash mark, any shaking, crack in the battery leg. Like this we have to check all the 10 batteries during the schedule inspection, and after checking we will reload the battery into the locomotive. Okay, after schedule attention, before loading the battery into the locomotive, we should check the DPT test of the battery box supporting clamp and battery box fixing bolt. The DPT test, by checking the DPT test, we can identify if there any welding crack or any defect in the battery box supporting clamp, and if there is any welding crack or any other abnormality, we should attend, then only we can reload the battery into the battery box. So after the complete checkup, we are going to load the battery into the locomotive. The battery should be loaded. After loading, we should insert wooden packs between the batteries, and it should be packed well. There should not be any movement of the battery inside the battery box. The batteries should be thoroughly fixed. There should not be any shaking of the battery during the locomotive movement. Next, we should ensure the proper tightness of the wooden blocks. After loading of the battery and packing of wooden blocks, next we are going to provide the connection. After providing connection, we are going to check the voltage of each battery. Now you can see in the multimeter, this battery gives us a voltage of 10.64 volt. Now we are going to check the health condition of battery by giving a resistive load. Here we have connected a resistive load between the battery. The load is connected between the positive terminal of first battery and the negative terminal of the 10th battery. Here we can see there is a voltage of 105 volt in the voltmeter. Now the battery, we can see we turn on the load. In ammeter we can see there is a current of 8.5 amps. Voltage a battery is giving, we are going to check. This is the load test of the battery. Now we can see this battery is giving a voltage of 10.25 volt. Like this we have to check the voltage of all the 10 batteries. Should apply petroleum jelly on each terminal. The petroleum jelly used to protect the battery terminal from moisture, to avoid terminal corrosion, and to ensure smooth current flow between the batteries. After the load test, disconnect the load from the battery and provide the theft rod across the battery box on both sides of the locomotive. Uh, the theft rod should be covered using a sleeve. After providing the theft rod, now we are going to load the battery box cover. The cover should be seated neatly, and the cover fixing brackets should be tightened well. For completion of the schedule, we should ensure all the bolt tightness, the battery box fixing clamp bolt tightness, and its welding condition. There should not be any welding crack or any type of crack in the battery box fixing clamp. All the bolts should be tightened well. All the clamp should be in good condition. It should be ensured thoroughly. Now we have completed the battery schedule. In the final phase, they provide the additional CCBA fuse in the fuse holder. It should be seated well, and close the additional CCBA cover. Finally, once more do a final checkup, and any pending bolt tightness, welding crack detection, any welding, finally complete all the final checkup, and if there is no any issue, we can turn on the battery of the locomotive and energize the locomotive.